Hi, everybody. We are looking right now at the third day, or the third part of our topic 10 notes. We're talking about trigonometric ratios, trig ratios. Okay, so some of this stuff is going to seem kind of foreign at first, but the more we talk about it, the more we practice with it. Hopefully, it'll start to make more sense. And even if you don't fully get it, if you've got a half decent pre-cal teacher in the future, you're really going to dive deep into this stuff. So let's get rolling on our notes. Okay, we need to start off with a couple of definitions of what I'm talking about when I use some of the terms that are going to come up when we talk about these. Okay, first term we need to know is hypotenuse. Now, this is one we're already familiar with. The hypotenuse on a right triangle is a side across from the right angle. It is also the longest side if you ever get confused about that. Okay, so on this particular diagram that's printed on your notes, on this particular diagram, the hypotenuse would be this one right here, AC. Okay, that's your hypotenuse. That is the longest leg of the triangle, or the longest side of the triangle, and it does not touch the right angle. Up next, we're going to be talking about an adjacent side. Okay, now the hypotenuse is pretty consistent. The hypotenuse is always going to be the part of the triangle that is not touching your right angle on the triangle. But these next two are relative, okay? And it all depends on which angle you're working with, okay? Trigonometry, we already said the other day that trigonometry is all about triangles. But these things that we're going to be talking about today are specifically talking about angles. Okay, and what I mean by that is when you look at an angle, when you look at the one that's marked in this diagram, we are working with angle C. Okay, angle A and angle B are not super relevant to this conversation that we're having. Okay, it's all going to be all about angle C. So when we talk about the adjacent leg, it's the leg of the triangle that touches the angle. That's not the hypotenuse. What we mean on this diagram, this would be the adjacent leg. Okay, the leg BC is the one that's touching the angle. So that's the adjacent leg. This next one is what we call the opposite leg. This is the leg of the right triangle that is across from the angle that we're working with. Okay, it's the one that does not touch it. In this case, it would be AB. That would be the opposite because we're working with angle C down in the corner. Now, I want you to look at these right here, okay? This time, we've got two other triangles. I want you to label the hypotenuse, the opposite and adjacent sides, okay? And I want to show you here that it all depends on what angle you're working with. This angle up here, obviously this side is going to be the hypotenuse. That one's pretty easy to tell because it's not touching the right angle. But if this is the angle that we're talking about, this side now is going to be the adjacent one. And this side down here is going to be the opposite. Okay, what I'm getting at, what the point of all this is don't just assume that the bottom side of the triangle is always the adjacent, because it depends. If you're working with the angle that's up here, the bottom is the opposite. Okay, look at this one. The hypotenuse again is the one that doesn't touch the right angle. But if we're working with this angle down in the corner, then the bottom one is the adjacent and the side is the opposite. Okay, it's all relative to whatever angle you're working on. So we're going to do a couple of examples of what this looks like, and we're going to talk about some more stuff within trigonometry. Okay, these are what we call trigonometric functions. Okay, trig functions, and what these things represent are the ratios of the sides of a right triangle: sine, cosine, and tangent. Okay, so it's going to be a little weird the way we define this, but hopefully it'll make more sense as we go through and we actually look at some examples of what this could be. Okay, so sine, cosine, and tangent are all things that you can apply to an angle of a triangle. Okay, so our example angle that we're going to be working with right here is the one in the bottom left of this diagram right here. Okay, the bottom left corner, it's labeled. By the way, that label is a Greek letter. It looks like a zero with a line running across the middle. That is what we call theta. That is Theta. Theta. It is a Greek letter, and it's really common to see that as a label for an angle. Okay, in all of mathematics, that's a pretty standard thing, is to see Greek letters that label your angles. Okay, so we've got sine, cosine, and tangent. The first one we're going to talk about, sine, is the ratio that compares the opposite side of the triangle to the hypotenuse. Okay, so the sine of this angle, the sine of theta, is this number over here divided by that number. The cosine of angle theta is this number, the adjacent length, divided by the hypotenuse. So we've got cosine equals this number divided by that number. The tangent of an angle, tangent is the opposite over adjacent. So it would be this number divided by this number. Okay, and we're going to do a couple of examples of what this looks like. But first, I want to talk about these things in particular. Okay, sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, tangent equals opposite over adjacent. Okay, you are working with opposite, adjacent, and hypotenuse all in different combinations right here. And it is very easy to mix those things up. So I want you guys, one of your Canvas assignments today is to come up with a mnemonic device to help remember it. Sine, opposite hypotenuse, cosine, adjacent hypotenuse, tangent, opposite, adjacent. Okay, these are some examples of different ways you can remember that SOHCAHTOA. Okay, some people just remember SOHCAHTOA going straight across, but a lot of people think that it's more useful to come up with an actual phrase or something to remember. So like this, some old hippie came a hopping through our apartment. Some old horse caught another horse taking oats away. This one is fun. Sophisticated oranges hopped carefully along, hoping to overthrow America. And I love that. You can just imagine fancy oranges with top hats and monocles in charge of everything in the United States. So I think that's kind of funny. Okay, so the one that I learned when I was in high school is this. Here's what it's pretty similar to this one here. Okay, the one that I learned in high school was some old hippie caught another hippie tripping on acid. Okay, and all that means is that sine goes with opposite and hypotenuse. Cosine, caught another hippie. Cosine, adjacent hypotenuse. Tripping on acid, tangent, opposite, adjacent. All right, so there you go. Now, this right here on your bottom of that next page. On the bottom of the page is an actual example of what you might see on your Canvas assignment today. Okay. First off, when we look at this triangle, we see that the angle that's being marked is this one right down here. Okay, angle theta, the one that we're dealing with in this problem, is the one down here. So in this particular case, on this particular triangle, the hypotenuse is going to be 13. The adjacent side is 12. And the opposite side, the one that's not touching the angle, is 5. Okay, so if we're dealing with the sine, of theta, well, sine goes with opposite over hypotenuse, some old hippie. Okay, so opposite is 5, hypotenuse is 13, so sine of theta is 5 over 13. Cosine of theta, came a hopping or carefully along hoping or caught another horse or caught another hippie in my example. CAH stands for cosine is adjacent over hypotenuse. So that's going to be 12 over 13. And tangent, through our apartment to overthrow America, that really is a good one. Taking oats away, or my favorite example, tripping on acid, is tangent, opposite, adjacent. So we've got opposite is 5, adjacent is 12, so the tangent of theta is 5 over 12. All right, and we're going to do one more example that's not printed on your page, but it won't take very long. and it's going to show you some interesting stuff. Okay, so the first one, okay, what we've got here is two different sets of trig ratios that we're trying to figure out. And the reason for that is because we've got two separate angles right here. Okay, theta is this one. Excuse me. Theta is this angle marked up in the top, and beta is this one down marked in the bottom right. Okay, so what we're going to do is we're going to do all of the trig ratios for both of these. So when we look at theta, you need to figure out which leg is the opposite side, which leg is the adjacent side. When we look at theta, theta is touching the side that's 3 units long. So what that means is that this one right here is going to be our adjacent side. So when we talk about sine, some old hippie, here, let me see if I can just type that out here. There we go. Okay, we've got our abbreviation there, and there we go. Okay, so some old hippie, opposite over hypotenuse. The opposite side that's not touching theta is 4. So opposite over hypotenuse would be 4 over 5. Looking at theta again, cosine is adjacent over hypotenuse. Caught another hippie, adjacent hypotenuse. So the adjacent side is 3. The hypotenuse is still 5, so it's 3 over 5. Tangent, tripping on acid, is opposite over adjacent. So the opposite side is 4. The adjacent side is 3 this time. So we get 4 over 3 for tangent. Now, let's look at this other one. Let's look at this other let's take a look at this other angle, angle beta. Okay, angle beta, we're going to do the same process. Sine is opposite over hypotenuse, some old hippie. Okay, so the opposite side on beta, unlike this one that we just did, 4 is no longer the opposite side. Okay, when you look at this angle alone, 3 is the part that's not touching it. So 3 is now the opposite. Okay, so now it's 3 over 5. Cosine, caught another hippie, we've got adjacent over hypotenuse. Now, unlike before, 3 is no longer the adjacent side. Unlike on these problems, 3 is now the opposite side. So that means 4 is the adjacent. So we've got 4 over 5 for our adjacent over hypotenuse. And TOA, tripping on acid, would be opposite over adjacent. So instead of 4 over 3, we're switching those around. We've got 3 over 4. All right. There are some Canvas problems today that are related to everything that we have done so far. There's some simplifying square roots. There's some of the 45, 45, 90 triangles. There's some of the 30, 60, 90 triangles. And then there's a few trigonometry ratio problems. All right. Y'all get after it. And please have a nice day. Thank you.